Everyone, welcome to this math tutorial series. So, if you are going to prepare for GCSE 9:1 or foundation course, so this tutorial may be helpful for you. Or accept all those bits as well. Say if you are going for any foundation course, or if you are looking for a basic math, then yeah, it would be useful for you. Okay. So in this tutorial, we're going to cover algebra, where we will be covering expressions, terms. We'll see what are like and unlike terms, equation, and formula. Okay. So let's just start. So what is an expression? So in general, expression is a collection of symbols so that express a quantity. Okay. So if we talk about maths, expression would be equal to uh, it would be having at least two numbers or symbols and one math operator. So we will see what expression would be having. So if we say as a notation, expression equal to number or symbols, then there would be a operator, that would be a math operator, and again there would be number or symbols. Okay. And the number would be like 1 2 3 4. Symbols could be x y z w, anything. Operator could be plus, minus, multiplication, divide. Okay, and divide can be also be represented as this sign. So this is a expression. So what we see as an example, so if we see x plus y, x minus y, or x minus y plus z, or all these are expressions. So what we see here, so this is a symbol, this is again a symbol, and this is a math operator, right? Plus sign. So if we see like x plus y, x minus y, this is all expression. We see a few more examples. 2x plus 3y. So this is like what we saw here. It could be at least two number or symbol and one math operator. So 2 is a number here and x is a symbol. Okay, so at least two number. So there should be at least two. So 2x. So this is a number, this is a symbol, then this is a math operator, and this again a number, then this again a symbol. Okay, so this is representing an expression. Now you can also understand that expression is something you can express something. Okay, so you could express as a number of house in total, or number of say goods in your home. So that could be anything which you can express, right? So this is also an expression. So if you see 1 plus 2, here what we see, 1 is a number, 2 is a number, and plus is a math operator. So similarly, if you see 55 minus 10, so this is also an expression. What it would be representing? This would be representing the sum of two, number 1 and number 2. So that would be equal to 3. Okay. Here this would be representing as a subtraction. 55 minus 10, it would be 45. Okay. So this is an expression. That means this is representing something, right? So just remember, expression is not an equation. We will see what equation means. But yeah, expression is not equation. And this is a tip to remember. So if you see E as an expression, it could be, you can remember it like NON or SOS. So it would be like number, then operator, then number, like we say here. Or it could be symbol, operator, symbol, like this one, symbol, operator, symbol. And it could be like number and then symbol, then operator, then it could be number, then symbol. So like this one, it is a number, then this is symbol, this is a operator, again this is a number, and this is a symbol. Okay, so yeah, you could remember like what expression means and how this looks like. All right, so next bit is expression and terms. So what we see as expression and what we see as a term, right? So if we see this one, this is representing x plus y. Okay, so this is something like x plus y. So this x and this y is called as a term. Okay, so these are which is separated by this math operator. So it could be any operator, it could be minus, it could be multiply, anything. So it would be separated by this operator. So this is term, and this as a whole is called expression. So if we see x plus y, this as a complete entity would be expression. So anything which is separated by this operator would be referred as a term. So here x and y are terms, and this x plus y as a whole is expression, right? So just to recap, symbol or numbers along with terms and operator is expression, like what we see here, and symbol or numbers are terms. So this is a symbol, or it could be like 2x plus 3y as well. So these we refer as a terms. Okay, and so operator will separate terms. So here this is the operator, so this will separate all these terms. It could be minus as well, it could be anything as a math operator. All right, so types of expression. So normally see the one type of arithmetic. So what would be arithmetic? It would be numbers and arithmetic operator, like what we see here, 100 plus 1, 10 minus 1. So this is a number, and plus is the operator, and again a number. So this is arithmetic, where we only see a number. The fractional is, it could be a fraction numbers and arithmetic operator. So just remember, in every expression you would see one arithmetic operator, and this would change. So if it would be number, it would be arithmetic. If numbers would be fractional numbers, it would be fractional, right? So like here we see example 100 divided by 10, 10 divided by 5. The third one is algebraic. So where we see algebra, symbols of variables and numbers and arithmetic operators. So examples are like this one is a square plus b square plus 2ab. So here what we see as symbols and variables and numbers. Okay, and this would be separated by terms. It could be plus, it could be minus, like what we see here. It could be anything as a mathematical operator. All right. So this bit is very important, which you need to learn, like and unlike terms. And if you're going for the GCSE preparation as well, you have to remember, and this is the mostly asked question, like which are the like or which are the unlike terms. So for the like term, if you have the same variable and same power, so just remember, if you have same variable and same power, so that would be a like term. And for unlike term, it could be a different variables or same variables with different powers. We will see few examples like what are like term or what are unlike term. But just remember, if you have a same variable, so if you have given two expressions and say two terms, if you have given two terms and you have to find out which one are like and which are unlike, then first you need to find out the variable. So you'll have to check if these would be having the same variables, and then you have to check the powers. So if they would be having same variables and same powers, then that would be a like term. And for unlike term, either it would be having different variables or same variables with different powers. Okay, and you have to remember that you don't need to compare constants ever. So whatever you see as a constant, you don't need to compare, and you don't need to look on variable orders as well. So if you see variable like x and y and x, then you don't need to care. You just need to check if they would be having same variable and if they would be having same powers. Okay, so let's see a few examples where it's more clear. Like here we have all these terms 10xy, 30xy, minus 5xy, and plus 2yx. So if someone asks you to find if these are the like terms or unlike terms, so what you say here, so 10 is the constant. What we saw, we don't need to compare constants, so we have to ignore constants. So 10, 30, minus 5 plus 2, just ignore this. Now check in all these terms, like x is to the power 1. So like you all aware, if there won't be any power, then by default so 1 power. So here we have x to the power 1 and y is to the power 1. So total is this one, x has 1 power and y has 1 power. So if you say here also x has 1 power and y has 1 power. Here also x has 1 power, y has 1 power. Here also y has 1 power and x has 1 power. So we don't need to confuse with with order. So x, y and y, x both are same because it's all multiplication. So if there's no sign in between, then that would be a multiplication, right? So in all these, so first what we need to check, if all these are having same variables? So yes, all these are having same variables, that is x and y. Then because these are having same variables, the next bit we need to check if all these would be having same power. So yeah, all these would be having same power, like x is having power 1 and y is having power 1, right? So this is a like term. And just remember, you don't need to look on order and don't need to look on the constants. So like here the constants are 10, 30, minus 5, plus 2, and order is xy and yx would be the same. Okay, let's see another example where it would be like 10 x square y, 30 y x square, minus 5 x xy, plus 2 y x x. Okay, so let's see here what we see. So in the first one, x is having power 2, y is having power 1. Here y is having power 1, x is power 2, but the order is different. So yeah, we don't need to look on the order, we just see that if it would be having same power. So yes, here also having same power. In this expression it's having x, then y. So that means we can write in this way as well. So when you write x and dot x, that means the multiplication. So when you add it, it would be x to the power 1 and x to the power 1, so that would be x to the power 2. So in this as well, we would be having x square y. Okay, so this would be having same. Then again y x x. So here order is changed, but if you see at the power, y is the power 1 and x was the power 1, then x to the power 1, it would be total x to the power 2. So in all these terms, x has power 2 and y has power 1. So these are also a like term. Okay, so let's see another example. So here it's having 5ab, 10ba. So again, like what we saw here, a is having one power, b is having one power. We don't need to look on the constants, so we can ignore these constants. And here also it's having b to the power 1 and a to the power 1. Okay, so in all these terms, in both two terms, a and b has both power 1 and 1. So this is also a like term. Okay, so let's see a few more examples. Okay, so in this one, 10x square y and 30y square x. So if we see here, x is having power 2, y is having power 1. We don't need to look on the constant, so just ignore 30 and 10. So here y is having power 2 and x is having power 1. So in this first one, x has power 2 and y has 1 power. In the second one, x has 1 power and y has 2 power. So here the terms, these variables are same, x and y, but it would be having a different power. So this is not satisfying condition, so this would be unlike term. Alright, let's see the second example here. It would be fourth example. So the fourth would be fifth one. So here 10x square y, 30y square x. So what we see, x is the power 2, y has a power 1. So in this first one, x has power 2, y has 1. In this one, y has power 2, x has power 1. Okay, so this is also not same, because here though we have same variables x and y, but we don't have equal powers here, right? So this is also a unlike term, right? So hopefully I think you need to be clear which one is having like or which one having unlike. So just to remember, for like, you first need to check what are variables. If you have equal variables, then you'll have to check powers. So if you get the same power, then those would be a like variable. For unlike variable, either it could be a different power, or if you find a different variable, right? Okay, so just tell me which are these, like or unlike. So here if you see, a has power 2, b has power 2. Here also b has power 2, a has power 2. But if you see, both are having the same variables a and b, and power is same here. Again, this is a b b. So if there's no sign, that means multiply. So if you multiply a and a, it would be 1 plus 1. It would be a to the power 2. Then again, b would be having b dot b. It would be b square. So it would be having same like this one, and this This also b dot b, it would be b square, then a dot a square. So all these are having same variables like a and b, and we would be having same power, that is 2, right? So these are also like terms. All right, so here if we see the second this example where it would be, if you can guess, so here a, so first is a square b, a is having power 2, b is having power 1, here b is having power 2, a is having power 1, here a is having power 3, b is having power 1. So if you see, all these are having different powers, though they are having same variables a and b, but they are having a different power. So all these are unlike terms, right? So hopefully that would be clear what are unlike or like terms. Just remember, yeah, you to be very clear, and yeah, it could ask this type of questions very frequently. And yeah, you need to be very clear what this unlike or like terms means. All right, so coming on equation, what does equation mean? So like we saw, if we see x plus y, this is representing as a expression. But if we say x plus y is equal to z, so if you are adding an equal sign, that would be called an equation. So you can remember, equation comes up with equal, equal, and that's come up with equation. So that's the way you can remember. So these x, y, and z are terms as we saw earlier, and this as a complete would be called equation. All right. So it's very clear. So if you say x plus y, there's a term, but yeah, sorry, x plus y, there's an expression, and x plus y equal to z. So that anything which is coming with the equal sign, that's the equation. So that's bit complete with equals is equation. So that's the way you can remember equals and equation. And remember, equation comes up with equal. So if anything comes up with equal, that's equation. Symbols or numbers are terms. Again, this is the bit which we learned, that anything which is coming as a symbol, so it could be 2x plus 3y is equal to 5z. It could be like this way as well. But yeah, anything if it would be coming with numbers, that's all terms, right? And operator with separate terms. So this is operator. It could be plus, it could be minus, anything. It could be divided as well. All right. So another very important bit, what is formula? So like you saw, what could be the formula? So formula is a set of rules to produce results, meaningful results. So that's a definition where what formula means. So if you say here, if you see, like if you need to calculate a volume or area, so volume for any say if you say need to find the volume of brick. So as we know, brick would be having height, it would be having length, it would be having width, and it would be having height. So if someone needs to find the volume, it would be length multiplied by width multiplied by height, right? So with the help of this bit, you can calculate volume. So in this case, it would be a formula, because this is something which is producing a result. So here result would be volume. Similarly, if you find something for the rectangle, you multiply length and width. So that's coming as the area. Okay, so here the meaningful result, or it's producing a result as the area. Okay, so this is we called as a formula. So this is the formula for calculating volume. Similarly, this is the formula for calculating area. All right, so things to remember, we can express formula as an expression. So this we can consider as an expression as well, like what we saw. If we say something like V is equal to LWH, so that would be kind of expression. LWH would be expression, right? Formula could be another form of equation. So like we see, if you see here, it would be coming as an equal sign. That doesn't matter whether this is part of it, this side or this side. So anything which is coming with an equal sign is the equation. So yeah, that's been satisfied. So formula could be in the form of equation as well. And formula and equation are exchangeable. All right. So both are like like bit. So if we say this is a formula, and we could also see this is an equation. So both terms or both things are exchangeable. All right. So that's all for this video. If you like this video or if you find this useful, just share with your family and friends. Subscribe the channel for such type of all videos. I'll be putting more videos, and don't forget to see the next video where we would be practicing all those bits. Alright, thanks for watching. Bye.